So this is lesson number 20, simplification of radicals and line parallel to a given line. Alright, so radicals, one of my favorites, we're going to look at today and just get an idea of how they can be split up and put together so that you can simplify them better and work with them in math. So for the most part, if you have the square root of a number and you want to take it times the square root of any other number, you just multiply those two and you're done. It also means that you can take that and split it up into the square root of 5 times the square root of 10. So you can go back the other way as well. So that's pretty much what that first half page is doing, is showing you the theorem that says you can do that. So in example 20.1, they give you an expression 3 square root of 50 minus 5 square root of 200. First thing we want to do when we get something like this is see if our radicals, our numbers under here, our radicands, can be reduced. So what we're looking for, and what I normally tell students to try doing, is before you spend a lot of time writing these as the prime factors of 50 and the prime factors of 200, what I try to get students to do is find two numbers multiplied together that give you 50. Where one of those you can take the square root of. So for example, I could take 5 times 10 and get 50, but I can't take the square root of either one of those. But if I took 2 times 25, that equals 50. And that also equals the square root of 2 times the square root of 25 from what I did right here. I split them up. Well, I know the square root of 25 is 5, so that can come out of the radical sign, and I get 15 square root of 2. So, 3 square root of 50 is actually equal to 15 square root of 2. Now let's do the same thing with this next one, and we'll do this in white. Square root of 200 can be written as, well, it can be written as 20 times 10, 50 times 4, 100 times 2, 25 times 8. So are there any, well, let's write some of these out. 25 times 8, 100 times 2, what else did I say? 50 times 4, okay, so the list goes on and on. 20 times 10. Alright, so what I said to do is look for the two numbers multiplied together that give you 200 that you can take the square root of one of them. Well, look at this. I can take the square root of 25. I can take the square root of 100. I can take the square root of 4. Which of these three do I use? Well, I always choose, and you can choose any one you want, but it will make your life easier if you choose the one that you can take the square root of when the other one is prime, or one that you cannot take the square root of. So this one cannot be reduced because it's a prime number. So the square root of, so this is, I'm going to take that one, I'm going to put 100 times 2. So minus 5, square root of 10 is 10, square root of 2, that can't leave because I can't take the square root of it. But this square root of 100, the 10 can come out. So now I have 50 square root of 2. Now I have a square root of 2 there and a square root of 2 there. I cannot combine these two terms if the square roots are different. I can multiply them if they're different, but I can't add or subtract them if they're different. But since they're the same, I can make this a 15 minus 50, which is negative 35 square root of 2 for your answer. Alright, so there's other ways to do this. This is just one of the ways, and I usually use this way because I can do a lot of this in my head. I can look at the square root of 200 and be like, oh, that's 10 times the square root of 2, because I pick the biggest number that I can take the square root of, and I know the other one's prime. Alright, so I end up with a mess if I were to pick this one or this one. I mean, it can still be done, it just takes a little bit of extra work. Alright, so let's keep going. Let's look at example number 2. Get rid of all this. Example number 2 says that we have 3 square root of 2 times 4 square root of 12, okay, times 2 square root of 3. So notice these are multiplied by each other, not added or subtracted. So I can multiply all this across and get 3 times 4 is 12 times 2 is 24. Square root of 2 times the square root of 12 is the square root of 24. Square root of 24 times the square root of 3 is the square root of 72. So I can do that. So I multiplied all of the numbers outside the radical to get that. And I multiplied all the numbers inside the radical to get that. That's one way of doing it. And in this particular case, it seemed like probably the easiest way to do that. And then I can reduce this. So 24, square root of 72, let's see, 36 times 2. And I can multiply 24 times 3, and I can multiply 6 times 12. I mean, there's all kinds of numbers I can multiply, but again, I'm going to pick that one because 2 is prime, so I know the square root of 36 can come out because this will change to square root of 36 times square root of 2, and the square root of 2 is as reduced as it can go, so that will stay there. So now I just have to take 24 times 6 is 144, square root of 2, and I'm done. Another way of doing this, and let me show you just so that you know that if things come up you're not stuck. We can change the square root of 12 to square root of 4 times 3, and then we can take the square root of that, and it would be 4 times square root of 4 is 2 times the square root of 3 times 2 square root of 3. Okay, so now I've got 3 square root of 2, multiply those. Okay, so now I'm going to multiply this, this, and this, and get 48. Then I'm going to multiply this, this, and this, and get the square root of 18. But square root of 18 can be reduced because I can rewrite it as a square root of 9 times 2. Well, what is the square root of 9? It's 3. So we can pull that 3 out. So now we've got 48 times 3 and get 144 times the square root of 2. Okay, so the answer is the same. I don't know that one way is easier than the other, but you can kind of determine which way you want to go. Do you want to start reducing in the beginning, work with smaller numbers? Do you want to reduce at the end? Doesn't really matter. Alright, so let's look at example 20.3. We have 4 square root of 3 times 2 square root of 3 minus square root of 6. Alright, because it's a minus sign right here, I cannot combine these because this number and this number are different. When your radicands are different, you can't subtract. So the only option I have is to distribute that 4 square root of 3. So 4 square root of 3 times 2 square root of 3 means we take the 4 times 2, and we take the square root of 3 times the square root of 3. Okay? Now we take this times this. 4, there's nothing to multiply it here, so that will stay. The square root of 3 times the square root of 6 is the square root of 18. Alright, this we know is 3. And 4, the square root of 18 is the square root of 9 times the square root of 2. Take the square root of 9 and we get 3. So let's do that. Let's do that. Okay, so at this point, you need to realize that these cannot be combined because this one does not have a radical and this one does. So that is your answer. That's as best you can go there. All right, so that's the first part of lesson 20.